All right, it looks like our numbers have stabilized, so let's go ahead and get started. Welcome everyone to today's CNCF webinar, Introducing Alterant, a transparent way to modify Kubernetes configuration files on the fly. I'm Caitlin Barnard, Marketing Manager at CNCF, and I'm going to be helping to moderate today's webinar. And once again, I'd like to thank everyone who's joining us today, as well as our presenter, Kash Sajati, CEO at Cloud66. So just a few housekeeping items before we get started. During the webinar, you're not able to speak as an attendee. So if you have any questions during the webinar, please use the Q&A box at the bottom of your screen. And we'll get to as many of those as we can at the end. If you have any technical difficulties or questions about the webinar, there's also a chat that I'll be monitoring as well. And then the session is being recorded and will be sent out afterwards, along with the link to the presentation. And with that, I'll hand it over to Kash to kick off today's presentation.
Thank you very much. Hi, everyone. Thank you very much for taking the time to attend this quick webinar we have around Alterant, one of our open source projects that we have sponsored and developed to help us migrate and move to Kubernetes in a safe and secure way. I'm very excited that we're going to share this with you for the first time. We have not publicized about Alterant very much. It's a new project that we're using in production ourselves, but we haven't really talked about it. So what I wanted to do is to just go quickly through a very quick intro, tell you a little bit about what problems we wanted to solve when we wanted to move to Kubernetes, what issues we faced, what solutions we look in the market to solve those, which led us to development and sponsorship of Alterant. And after that, show you another couple of our open source projects that we've talked about more before and are more popular. Obviously, they've been around for longer. And then I'll be more than happy to take any questions you might have. So first of all, who am I? Just a quick introduction. My name is Kash Sajati. I'm one of the co-founders of Cloud66. At Cloud66, my role is to take care of mostly business and product strategy. But we started Cloud66 back in 2012 with an aim to help developers build infrastructure in a way that's forward-looking and compatible with the cloud days. So that's when we started in 2012. In 2014, we rolled out our products around containers. 2015 was the Kubernetes year for us when we started using Kubernetes, and we moved ourselves, our SaaS product, which was running on AWS EC2, old style, quote unquote, infrastructure onto Kubernetes. And this product, or the project that I'm talking about today, Alterant, is a result of the issues that we saw around this migration and primarily around the deployment of our own product into Kubernetes. So what we had was a standalone, very standard, I should say, stack that was running on AWS. What we wanted was to streamline this process of deployment of this application so we can deploy out more than one environment that's production. We wanted to be able to have the entire stack end-to-end for every Git branch that we have. We also wanted to have one environment for every developer that was in the company. Wanted every developer to have their own instance if they wanted to. So have these ephemeral environments of the entire application with databases, storage, everything, all the components just come up and be usable and then folded away. So you can imagine that's a really good way of showcasing new features, testing new functionality, running automatic tests and CI/CD tools. It is an ideal situation for a SaaS business to be, so we can move faster and iterate faster. That was the idea, the goal, what we had. But we also had some requirements. First of all, we wanted to have as few as possible number of clusters. We knew that Kubernetes itself can really help us with achieving that goal by having each instance of this stack in for example, a namespace. But we didn't want to have multiple clusters and manage lots of clusters, upgrade a lot of clusters, pay a lot of money for a lot of servers that will be essentially a redundant resource for us. So what we wanted was the most cost-effective and fast way to have these ephemeral environments of everything we have in the system. That was the first requirement. The second thing we wanted was to remove what I call magic. And what I mean by that is we wanted to take away anything that is not understandable and obvious and visible by just looking at something. We didn't want our developers to commit code, roll out something, deploy something, and then some magic happens that things just work, but they don't know how it works. And the reason we didn't want that magic was when something doesn't work in a magical scenario, then finding the issue is very difficult. So when things work is great, but when it doesn't, it's a nightmare. So we wanted to remove that magic and make things simple and understandable, which would help us also onboard new teams new members to the team. So when some new hire and an engineer joins the team, they can understand the system as long as they have a fairly standard understanding of upstream Kubernetes, what Kubernetes paradigms are, and they can get started very quickly. And the third objective that we had was what I call being able to use Stack Overflow. Now, we all know Stack Overflow is pretty much all developers or globally's best friend. What it means is, if I have an issue with deployment of something on Kubernetes, I don't know how to set a static IP address for a load balancer on Kubernetes, for example, or I need to know what is the specific annotation I need to put onto a service in Kubernetes manifest to get a specific behavior around Nginx ingress control, or whatever that question might be. I can go to Google it, and usually I land on a Stack Overflow or some similar website, either it's CNCF documentation around Kubernetes or some other thing that I can use. What I mean by that essentially is that we wanted to have the vanilla upstream unadulterated version of Kubernetes running on our infrastructure. We didn't want to modify it so it does what we want it to do, but then lock our developers out of using the standard Kubernetes version. And a lot of the cases that we see in the market are based around that, whether it's because they want to control access to the cluster, they want to make usage of a cluster safe and secure for everybody else, they kind of lock it out and wrap it inside an API of their own, or add some magic that will make that cluster or infrastructure compliant with what we have, what they want, but cuts out developers from the big community of developers that are around that can help them achieve their goals faster. So with those requirements, we set out to find out how we can get there. Now, as you can imagine, as you've used Kubernetes before, I'm sure, you can see that if you have a fair amount of services within your application, let's say 10, 15 different microservices that you have, whether they are necessarily microservices in the true sense of word or just different services that talk to each other every often, your Kubernetes manifest files can get quite big. An example of that is if you have 15 services, you probably have 15 deployments and 15 services next to them. So that's quite a good amount of configuration YAML that you have. As well as that, you have namespaces, persistent volume, declaration, and claims. You might have ingress controllers. You have all these bunch of different things that, depending on how you slice and dice it, how you manage your files, how you split them into with naming conventions and all the best practices, you end up with quite a lot of files and quite a lot of configuration. And while that's not necessarily an issue, modifying them could be. An example of that is if I have if I'm running on Kubernetes on Google, just an example, which is something that we tried on GKE, and you want to use Google's database as a service, SQL, Cloud SQL. The way to connect to that SQL is to have a specific, Google's recommended way of connecting to the database is to use a sidecar within your pod. Now, for those of you who are not familiar with sidecars, just quickly, as you know, in Kubernetes, pod can contain multiple individual containers. And a sidecar is a container that you insert into a pod that then does something for the sibling containers. For example, it could be a log collector that collects the log and sends the logs that are generated by the application to syslog or some other external log collection agency. Or it could be an encryption at rest system that all the writes are going through it. Or in this case, in case of Cloud SQL and GKE, it is a proxy that sits between your application and database and facilitates communication through connection pooling and authentication the way Cloud SQL likes it. What it means is that if you have a single SQL instance on GKE, for example, and you have 15 services, you have to insert this configuration into every single one of those pod definitions every time you deploy. Now multiply that by the number of ephemeral environments that you have, and then you end up with a mess. Every time there is a change in the password or the SSH keys or a change in the configuration and environment variable, for every single one of those, you have to go back and make this change. And while all of those changes can be regulated, can be modified and viewed, you can get to a point that this becomes just not manageable with normal resources that we had. We try to obviously keep all these configuration files in Git, but that's not necessarily going to solve the problem. The second problem that we had was, as I said, we wanted to have as little as possible infrastructure footprint. We wanted to reduce that to just probably 1 or 2 clusters. And what we ended up with was, before Kubernetes, we had Snowflake servers that were only doing specific things, and we had to be configured to do those things. And then after Kubernetes, without these tools, we ended up with a lot of Snowflake clusters. For example, if we wanted to deploy our application onto GKE, as an example, we had to configure some little things slightly differently, whether it was about the persistent volume classes that were available, or about the availability of a specific load balancer type that we wanted. And if we wanted to deploy the same application to another cluster, let's say Minikubes or something that we just put together ourselves with another third-party tool, we had to modify those configurations just ever so slightly so they can work together. And this meant that instead of Snowflake servers, we ended up with Snowflake clusters. Again, something we didn't want. We wanted to be as simple as possible. So then, as a result of that, we went out technically shopping, looking for solutions that we can use to solve those problems. The first thing we wanted to do was to fix this whole thing by automating generation of the configuration files. Obviously, the first solution is just to do it manually, which is what we started to do. We make the changes manually. We go around every configuration file every time and something changes. We have to apply to all these configuration files, commit it into Git, and keep our fingers crossed for some so we don't make human errors and things not to break. And that's not ideal, but it's the cheapest way to start with. It gets expensive very quickly when you make a mistake. The second solution, which is way more advanced than anything that we would have been able to do at the beginning, was to do something using admission controllers. Again, if you're not familiar with admission controllers, think of them as a hook that sits on Kubernetes cluster itself, intercepts API communication between the client and the cluster, and makes changes to those API requests. An example could be application of that through access control, or, for example, it could be the injection of a secondary container within a pod to facilitate communication with a SQL, as we talked about in case for GKE. Now, admission controllers are great in terms of automation, but they add magic. Technically, what they do is that you commit a configuration file that you know doesn't have a pod sidecar, and all of a sudden a sidecar shows up when you look at the production. And unless you know explicitly somehow that there is an admission controller or a set of admission controllers at work on Kubernetes, then on this specific cluster, you would be confused. And we did not want that. We love admission controllers and they are very good for certain purposes, but we didn't want to overuse them. The second thing is we wanted to be able to just deploy a cluster and use it the way we would do it with any off-the-shelf or managed Kubernetes cluster without having to go and modify it every time, add our admission controllers and all sorts of things around that. And admission controllers were not necessarily suitable for that purpose. So what we did was we decided to write a small tool, which then grew into something slightly bigger, open source it, and we called it Alterant, which is an open source tool to modify Kubernetes configuration files using scripts. It's a fairly simple concept. What it does is that you give it a Kubernetes configuration file, and you write a script that's written in JavaScript, and it runs that JavaScript in a safe and secure way to modify the file. So it's very simple, which is what we wanted. We wanted something simple. And all the details and all the intricacies of this tool is around making sure those scripts are written in a way that is simple and intuitive in terms of understanding them. And also these scripts can run in a safe and secure way on our build servers or our CI/CD servers, so we don't end up with potential security risks if we let any external script to come in and run. So with all that context, I'm going to jump right into a demo and show you 3 demos. So the 3 demos that I want to show you is, first one is a very simple one. The basic thing that I want to do is just automatically add annotation to all services in my configuration files. And that's a fairly simple one. So I'm going to share screen, not the screen with you. So this is a simple file that I have. It's a configuration file. As you can imagine, it's a very simple one. It's just the namespace. And after that, I have a deployment that deploys a specific pod, starts it, and a service that then looks back onto that deployment. 3-piece, nothing very complicated. And what I want is I want to annotate this service with an annotation here that says something like cloud66.com/deployed on deployed at some date. Let's say this is one of our best practices. Let's say this is what I want to do, just to make sure that all services are stamped with the dates that they were deployed or a specific one. Now, this is obviously a simple example, but deliberately simple so we can focus on the script instead of the purpose. So if that is my configuration file, the next thing that I need to use Alterant for this is a JavaScript file. So this JavaScript file goes and says, if the item that you are inspecting is a service, as it is here, if kind is service, then for that item, metadata annotations add an array that says cloud66 deploy that date now. It's fairly simple. JavaScript is a very popular language. Obviously, a lot of people know it. If you don't, as long as you can code, you'll be able to figure this out. The only specific thing here is this $sign. So it's a shorthand that we created, which means when Alterant runs, it goes through every one of these pieces of YAML, each one of these sections of YAML. This is the first one, the second one, and the third one, and then replaces the entire value, reads the entire value into this $sign variable, which is we borrowed from the jQuery syntax, and then gives you access to that, so you can inspect and modify this. And the other kind of tiny thing around this is that any change you make here gets persisted back into the object. It doesn't necessarily get written back into the file, but it gets persisted, so you can inspect $sign after this and see what changes have been made. So let's see how it's in action. So I'm running Alterant from the source code here, and the way it works is fairly simple. I'm just going to give it a file. The file that we had were, I think, sample YAML. And then the modifier that we wanted to use was samples add annotations. If I can get the, sorry, I forgot the command, obviously. Alterant modifier. Right. So as you can see here, you saw that file that we had at the beginning, sample YAML. Here we have the sample YAML again. They're just bumping it out into standard output. You can add an out, which you will see that will just write it to a file. But here, nothing's changed except for this case where we just added the annotation that we wanted to this file. If I run it again, this number is going to change because that's the current date. And that's fairly simple usage of this. It's a very simple one. Now, Alterant can consume YAML, can consume JSON as well, and output YAML or JSON as well. So if you write your configuration files in JSON, you can use them with JSON. Or alternatively, what you can do, you can use kubectl to pull out the configuration files from an existing cluster, run it through Alterant, and push it back in if you want to make changes to an existing cluster without having the files that you have. So you can just do a kubectl, describe something, or get with the name -o YAML, which gives you that, and then pipe this into Alterant, and then get the output pipe back into kubectl, which means within one command, you make a change using Alterant. So that's the first example of using this. The second demo that I wanted to show you was add a sidecar to all deployments. Now, this is more interesting, obviously. The first one was just to get you started. Add a sidecar to all deployments. So what I want to do is that exactly the GKE issue. On GKE, again, you need to have such a secondary container that runs on all deployments. And I want to do this automatically. I want to configure this secondary container once, and I want to inject it into every deployment that I have. With Alterant, that's fairly simple to do. So back onto my samples. So here, I have the sidecar configuration. As you can see, this is just a partial configuration for the sidecar that I have. It's not the entire deployment definition. It just starts with the image, which you would imagine is the one that I want to put inside of the container. So if you think about it within the context of our sample file, here is my deployment, and here's the containers that I have. And within that container, I have one image, which is my application image, and I want to insert another one right here with the sidecar. So what I need is to just define the sidecar right here. And this is what I've done. This is a real example of a Google SQL proxy that this is the definition and the configuration that it needs. And you can see that this is not necessarily a very one-liner configuration. So if there is a change in this and you want to make a change or rotate the keys or whatever you want to do, then you would have to do this everywhere on every single configuration that you have. Here I've created the JSON version of that just to show that we can consume JSON as well. It's the same configuration, just defined in JSON. Now, how do I add the sidecar? So in Sidecar, again, I'm going to check for the kind is deployment. I load all the templates, all the containers within the spec of this template into this. And if there is length 1, which is something that I just wanted to show, that we can check how many containers do we have in this pod. Not that, you know, I know we're not going to have more than one, but in this case, I'm just checking if the length is 1. I can load the file that we had with a definition of the sidecar, load the sidecar image from there, load the container image, use the tag container sidecar image, and push that sidecar into my into the containers. Now, these lines are quite interesting. So here you see that the first thing that I'm doing is I'm loading this sidecar JSON, which was the one that I showed you here, my sidecar definition. So I'm loading that first. And this JSON read is a function that Alterant provides you, so you can just load JSON. You have a YAML one as well. Another thing that you can find here is that the Docker image. So Alterant also gives you these helper functions around or classes around using some specific container or Kubernetes specific paradigms. In this case, I'm loading the sidecar image just to get the sidecar image tag, which would be in this case this tag, this name of GCR Cloud SQL Docker. I'm loading that into a variable, and by using Docker image helper, it basically understands what the image is. So what it does, it basically parses that into repository, image name, and tag. And that way, I can access different parts of that container image. I'm also loading my containers, the first container, and as you can imagine, because the length was 1, I'm using my container image itself, loading it as an image. And here what I'm doing is I'm just using the tag to change the tags, so I'm always consistent across all of my images within the pod. This is something that I want to do because I have this snapshot policy that everything within the pod should be tagged with the same tag, because that's just what I wanted to do as in a policy within the company, but you don't have to do any of this if you don't want to. And then the last thing that I'm doing is I'm getting the address, as in the repository, the registry, the Docker registry, for my Sidecar image, and insert it as the image, and I insert it into, push it with an array push in JavaScript back into containers. And let's see how it works. Okay, so here I have sample. And I'm running it with JavaScript, with the Sidecar.js. So here, as you can see, now my containers, this was my first one. And now I have the secondary one loaded into this with all the configuration that came with it as a sidecar all the way, and nothing else has changed. Everything else stays the same. Okay, so that was an example of adding a more complex setup and loading it from a file, and an example of a helper. Now I'm just going to go into the helper and show you. You can actually write your own helpers if you want, but this is a just a simple one. So here, Docker image class. Here's again, it's written in JavaScript, so you can add your own if you want to. And it's just a JavaScript class, very simple. As you can see, it just parses that, so you understand some of the nuances of Docker image system, naming system around. If you don't have a repository, it means it's Docker.io, index Docker.io, and things around this. Nothing very specifically difficult, but it does the parsing for you, so you can get values like the fully qualified image name, registry URL, name and tag pulled out of an image, full image name that you have in there, so you can do things around changing the image name or changing the image tag. Another one is around understanding, for example, another helper is around understanding ports, so you can get the internal and external ports, so you can swap them around if you want, you do anything else around that if you want. And then containers is another one that understands containers, so you can run it by name and find the container by name. And these helpers are just sampled helpers that we have. Now on to the third and last demo. Change the manifest depending on the cluster. Now, this is not as complicated, but it's actually nevertheless very useful. This is something that we found around when we wanted to deploy something onto different clusters and we had to make specific changes. A simple example of that, if you want to deploy something onto a Minikube, load balancer was not supported until recently. It is supported now, but you couldn't have a service that has load balancer. But on most other clusters, you can have a load balancer as type of the service. And you can imagine, for production, you want to pay for a load balancer, you want to have it load balanced. But if you have a developer-specific cluster, you just want to fire up on your machine and use it, you necessarily don't need a load balancer. On the other hand, we didn't want to have two different types of configuration file, one with the type load balancer, the other one with the node port or cluster IP, for example. So we just want to try and see if we can use Alterant to add a load balancer type depending on the cluster destination. So here is, again, another simple way of doing it. I'm just checking the kind again, if it's service, and add a type load balancer. And here's an example if I wanted to. I commented this line out, but I can add an IP address if I want to the load balancer. If in this specific case, my cluster has a specific load balancer. For example, for your production, you probably have a specific load balancer IP that then is configured with your DNS. And if I wanted to run that, again, it would be fairly simple. As you can see here on my service now, using my, oh, there we go. Sorry, my window was covered itself with the Zoom window. There, so it added the load balancer type here. One of the things that we are working on is to allow runtime variables to be passed into the script. So you can actually run this command with something like build arg and say something like use load balancer, which will then be checked, and you can check it in your JavaScript and make a decision whether to add a parameter or not, instead of having everything explicitly defined in your JavaScript itself. So lastly, I just want to show you some of the scripts that might be slightly different. This is, I'm adding here, what I'm doing here is that this script, this Alterant script, adds an entire new service, a new deployment to the manifest. So regardless of what the manifest is, whether it has any deployments, whether it has a namespace or whatever that might be, I'm just going to add this service to it. For example, this is quite useful if you have a specific deployment that you want to have on every deployment of every application cluster or namespace that you have, whether it's something like a monitor that looks at cluster events, or something that you want to deploy every time, regardless of what application that is. So what we are doing here is beginning the namespace, so we can just install that, deploy that deployment onto the same namespace. And here I'm just defining the entire thing as you're familiar with it in just JSON, fairly simple. And here is another shorthand, $, which basically is the root of the whole manifest file that's out there. So I created this deployment variable, and I'm pushing it up 2 levels up into the parent. So now, alongside everything else that I have another deployment as well. I'm going to run this as well. I haven't actually tested this one fully for the demo, but I'm going to try my luck. So this one is add service. And there we go. So what happened here is that you have here you see that this deployment was added to the same namespace as the one that I defined in my example file. So now every time I want to deploy something, automatically it adds this. Now, this is fairly simple, as I said, but it's very useful. And I kind of like both cases, that it's very useful and simple at the same time. It's very easy to grasp the idea and write scripts for it, but it's very useful. We find it very useful. And one thing that you might ask is, where's transparency in this compared to some other way, like admission controllers? So what we do with this is that we have our configuration file manifest in a Git repository where we just take them out and run them through Alterant. And we also have another couple of open source projects that I just touched upon. And we run that through the pipeline. And at the end of it, another set of files are generated that then can be committed back into the Git repository. And if we have an automatic deployment system that just pulls it out of that based on a Git commit hook and deploys it, that's okay, that's automatic. But what it means that we can inspect and look at every change that was made, whether it was manual or was done automatically through Alterant. We can inspect it and we can verify it, and we can trace it back as to why and how and when did it happen, instead of pushing something into a cluster and automatically having it intercepted and something happened to it without any trace of it. And that's the purpose that we wanted to do. That's the reason we wanted to have transparency around that. Another open source project that we have is called Habitus, which we talked about before. It's a multi-step Docker build, and it also supports secrets during the build, so you can use it to inject secrets into a build during the build without leaving any traces on your image, which is quite useful if you have a private Git repository, for example. You need the private SSH key to run your build-dependent builds or any API keys that you need during your build. That's quite useful for that. You can check it out on habitus.io. And the last one is called Copper, which we actually talked about on another webinar with CNCF, which is another open source project we have. which you can write scripts for verifying your Kubernetes scripts, Kubernetes manifest files. So within your pipeline, you are sure that they're not going to deviate from your policies. For example, nobody's going to put an image with the latest tag in there, or nobody's going to change the static IP address of a load balancer. And if this happens, then the copper will catch them and it will fail the pipeline and deployment will not go through. Again, this is fairly simple stuff that it can do, but it's very useful within the pipeline. You can find it in copper.sh, which is the website for it. At this point, I'd like to just ask if you have any questions, and thank you very much for your attention.
Awesome. Thanks, Kash, for the presentation. So we have time for some Q&A now. Just a reminder, you have a Q&A tab at the bottom of your screen. So if you'd like to ask anything, please drop it in there. I'm going to start with one that's from a little bit earlier in the presentation. What about custom resources to encapsulate differences between environments?
So custom environments, custom resources are very useful for this, and definitely we can use it for some of the things that Alterant can use for it. One thing is, obviously, for a custom environment to be available, we don't want it to be part of a development deployment. We want it to be part of the ops deployment of a cluster. So when the cluster is deployed, we want to kind of prime it with all the custom resources that are configured with it, as opposed to nominating the first person who deploys it to be the one that deploys that custom resource as well. So that's the first thing. We wanted to reduce the time to have a working cluster by making sure that if you just go and run Minikube, install Minikube on a laptop, we can run scripts on it without having to prime it with custom resources, admission controls, and everything else. But it doesn't mean that custom resources are not a solution for this. We think of custom resources mostly for other purposes other than modifying the configurations. An example of that is certificate management, for example, for Let's Encrypt. That's a perfect example of something that you can use a custom resource for. I hope this answered your question, but yes, definitely that could, if you want to, you can achieve the same goal with it. We don't think that is necessarily built for it, but obviously it's yet another way of doing it.
And then we have a couple questions on Helm here, so I'm going to combine these. How does this interact with Helm, or how does this compare to kind of using Helm to address the same problem?
So Helm is, first of all, it's a very good question, and it's a very valid one. What we see Helm as is a package manager, not necessarily a deployment solution. While you can obviously package your application into a package, but the way I would always compare how Helm with like non-container based or non-Kubernetes centric solutions is comparing Helm as a package manager with NPM for Node.js, for example, or Ruby gems for Ruby, or Go packages. You get the idea. It's mostly a package manager, which is very good for two things. One is managing third-party entire applications being packaged up within in their entirety. And the second one is when you have something like a dependency, something that needs to be deployed. Example would be a custom resource that you just use Helm to deploy it. Now your cluster supports this specific new type of custom resource, or anything that's used for priming a cluster. For example, allocating specific persistent volume types. So that is what I see as the primary use for Helm. But it doesn't mean that we cannot write a script for Helm and write a chart that will deploy our entire application. Some of the limitations that we see with Helm when it comes to deploying an entire application, not necessarily that there's anything wrong with Helm itself, it's just using Helm for the entire application. One is primarily around issues around secrets that obviously are still being discussed, how to solve them, having secrets in the files. And the second thing is around, it's mostly about packaging everything. So the chart that you write is about what should be deployed and how it should be deployed. It doesn't necessarily help with how to modify this for different environments, for different clusters. You can do it with if statements and having some scripting around it, but what we wanted was to avoid having a complicated workflow within the Helm chart that says, if my destination is Minikube, then behave this way. If it is environment is production, then behave in a different way, which doesn't really lend itself to modifying a structured data file like YAML, usually those scripting languages like Go templates or Arab and other similar things that are used in scripts like this are built to render web pages that are not as structured as or specific about indents or anything else around how data is presented in a YAML, like a YAML file. So we wanted to make it easier, make our developers' life easier around that.
All right, and another one here. How or does Alterant work with Istio or Envoy?
Yes, it does. The best way, obviously, to if you think about how service meshes work, usually is they usually work through a sidecar primarily. And that's usually happens either you manually go and change it, or in case of, like, for example, Istio, you can pipe it into Istio, pipe your manifest file into Istio, and it will automatically inject the Istio sidecar into every service that it finds relevant. And that's how they usually work. And Alterant is exactly the same thing. It does work by injecting something that you script out onto exactly where you want it to be, but it's more generic than that. Istio just takes care of Istio injection. With Alterant, you can use it for Istio sidecar injection or Envoy, but it's not limited to that. And it also has you will have a little bit more control about what you want to inject into it, as opposed to having just a pipe that goes in, takes the file, and puts it into it. But definitely they can work together.
All right, and then a clarification on some stuff that was demoed. Do you commit the output from Alterant?
We do in our team. So Alterant itself is just as a modifier of a file. What it does technically behind the scenes or under the hood is it runs. What it does, it creates it uses Chrome V8 to run the JavaScript within an isolation that is that protects malicious code. Well, protects your system from running malicious code potentially in your JavaScript. So yes, it runs on V8, and that's all it does. It just takes in a file, runs the JavaScript with some helpers that you saw. The output could be onto the standard output, or it could go into a file. As part of our pipeline, and SkyCap is a product that we have at Cloud6 that exactly is integrated with Alterant to do this. We take the input file from the Git, and then we run Alterant scripts that we want on each step, and then we validate the output. And if a validation through Copper is all valid and everything's good, it runs the tests and everything is good and thumbs up, then we commit that back into Git repository. And if for some repositories and for some clusters, we have another system that is hooked with a Git commit hook, and then after every commit back into the repository, we'll pull it out and run it against the cluster automatically, so the deploy goes the whole way. But we do it in steps, so we can have steps that we can inspect and stop and interject and review and make sure everything is okay before it automatically goes into the next step.
Awesome. Another one, how do you manage sets of variables for different environments? For example, ingress URL differences for different environments.
That's a very good question. So this is kind of what I touched upon a little bit around runtime arguments. So the same way that with Docker build, like a vanilla specific, very tiny Docker build that you might have, you have environment variables and build arguments, and build arguments don't end up inside of a container. They're just used during the build. What we are doing for the next version of Alterant is to allow you to pass in either a file or a bunch of build or runtime arguments into the command line that are then available to a script. So in your JavaScript, you can say if a build argument is as such value or this environment, then take this code path. And this is obviously much more readable to do in a programming language that's written with the intent of using control flows like ifs and for loops like JavaScript, than having those conditions within switching between two contexts in a YAML file, which is used with something like Go templates, where you switch into Go, write a little bit of Go, and then go back to YAML, and that makes the whole thing is a little bit kind of difficult to read. We can pass these arguments into JavaScript, make a decision as to what modifications we want to take based on each one of those build arguments, and then spit it out as a result.
All right, and can you pass variables to Alterant like a command line argument that could be used in modifier scripts?
I think that was exactly what. Yes, so that's exactly how I was trying to suggest that what we're going to do in the next using build arguments. Yes.
Perfect. And do you have any plans to support future plans to support the ability to modify the deployed config maps instead of fetching to local?
Any plans to support in future to modify the deployed config map instead of fetching to local? I'm not quite sure if I understand the question in full. We do. So config maps are, as obviously they are part of the manifest. They can be part of the manifest if I get the question right. As config maps are part of the manifest, they can be defined in the manifest. Therefore, Alterant can make changes to them. They can modify the config maps. However, if you mean by modify the deployed config maps, as in the ones that are already on the cluster, yes, you can use Alterant on a running cluster. So the way that we would do it is you just simply run a kubectl command. Basically, in principle, you pull out the configuration from the cluster, you convert it into JSON or YAML, pipe it into Alterant, and get the results back and do whatever you want to do with the results, which could be piping it back into the clusters itself. So just kind of a pseudo thing that I'm sharing here would be something like kubectl get, say, config map foo, and I'm going to get it as YAML, and pipe it into Alterant, modify it with such files, configuration and everything else, and then push it back into kubectl, apply -f-. So this will pull something out. Now, it could be a config map, it could be anything else that you want. It pulls it out, turns it into YAML, feeds it into Alterant, Alterant modifies it, then pipes it back into kubectl, so it goes back onto the cluster. So you can do this if you want to. It's not very transparent, but it's a single command. You can make modifications onto an existing cluster.
And then does Alterant validate and report specific errors in the input YAML? Put another way, does Alterant cope with errors and help troubleshooting?
That's a very good question. So there is basic validation. If the YAML is completely invalid, obviously Alterant will complain and will cry. But Alterant's job is not validate the YAML file specifically around Kubernetes. One of the open source projects that I touched upon at the end, Copper, which you can find on copper.sh, is exactly built for that. So it has a very simple DSL that you can define not only the validity of the YAML file, whether it's like constructed correctly, the indents are correct, tabs versus spaces and all that sort of stuff that are syntactical, but it also is about the specific validity of something in regards when it comes to Kubernetes. You can not only the valid universal validity of that in sense of, do we have an image attribute, but more than that, you can go more than that in Copper and say, not only do we have to check whether we have an image, but it has to have this specific name, come from this specific repository, and have this specific range of versions. So with Copper, you can even apply policies around, I let my developers upgrade minor versions of, say, MySQL into my cluster, but not major versions. You can even do those things. So it goes beyond validity into compliance. But that's Copper, not Alterant.
Great. And then going back to Istio and Envoy, are there any Alterant samples for that yet, or maybe any plans to put some of those together?
We are working actively on Alterant to improve the code, to make it more accessible and document it better. As part of the documentation efforts, one of the things that we're doing is we're working with existing open source projects around Kubernetes ecosystem to create examples and samples of how Alterant can make their deployment easier. And that includes Istio and Envoy, as well as other things like using it with Helm. So one of the things that Alterant can modify, as you can imagine, any YAML or JSON file. And for example, values YAML in Helm is another YAML file. So you can use Alterant in conjunction with Helm come up with different variations of a Helm chart as well. So that's part of on our roadmap to create those samples and publish them as part of our documentation.
Awesome. Well, that looks like it brings us to the end of our Q&A today. Thank you everyone for those great questions. And if you thought of something afterwards that you'd like to ask, feel free to email us at webinars@cncf.io and we'll get those to Cash. Once again, the webinar recording and slides will be online later today. And thank you all for joining us, and we look forward to seeing you at a future CNCF webinar.
Thank you, everyone.